Hey, welcome to video 1-4B. We're going to continue using this idea of proofs that we introduced in the last video to go ahead and start using it in some geometric situations, okay? At the top of the page here, and I am on page 48 with you guys, they introduced to you a new theorem. Remember, theorem is kind of like a name for rules in geometry that you can prove. A theorem here about a linear pair. So first off, definition-wise, two angles whose measures add up to 180 are, as we know, supplementary. That is also sometimes called a linear pair when those two angles are adjacent and form a straight angle or a straight line, okay? It's, as it says, it's a pair of adjacent angles, so here 3 and 4 are these adjacent angles whose non-common sides are what we call opposite rays. Those sides, meaning the side that's not shared between the two, this side right here and this side right here, opposite rays are going to make up the two parts of a line. They go in completely opposite directions. And it says we're going to prove this in an exercise in this lesson. We can also talk about some other theorems, the linear pair theorem, as well as the two postulates that we learned before, simply broken down as small plus small equals big. Remember, two smaller pieces of a segment equals the sum of those two segments. Two smaller pieces of an angle equals the largest angle that's in that diagram. So we're going to use those ideas there in the next couple examples. Example 2, use a postulate or theorem to find the value of x in each figure. So we're going to go through here and kind of justify the steps like we were doing, but now we have a geometric diagram to start out with, okay? So example 2, we have two segments next to each other, adjacent, RS and ST, that we know are going to be able to use our segment addition postulate with, okay? So it says, given that RT is 5x minus 12, RT meaning the whole entire distance is 5x minus 12, that's why you see this whole distance labeled there, use the segment addition postulate, RS plus ST equals RT, to basically solve for x. So all we have to do, you guys, is substitute the algebra label for each piece and make an equation out of it with x. RS, this first part, has the label x plus 2 in the diagram, so that's substituted there. ST has the label 3x minus 8, so in place of ST we're going to put 3x minus 8. And then RT in the diagram has the label 5x minus 12, so that gets substituted in there. Okay. Next step is simply adding and adding like terms. We've got x and 3x gives me 4x, and 2 and negative 8 gives me negative 6. So now we have this equation right here. And how did we go from here to here? Well, that's going to be just the addition property of equality or subtraction property of equality, depending on which one you want to use. I'm going to choose to move the x first, so if I want to get rid of the 4x and bring it over, that gives me 6 equals x once I add the 12 and bring it over to the left-hand side. So we have x equals 6 to solve this example through. And notice what we did is we started with small plus small equals big, and we made an equation out of it. So as we go to the next page, page 49, we're going to do the same thing, only now we have an angle, okay? So this time, instead of using the segment addition postulate, we of course are using the angle addition postulate. And you just need to be careful with the labels here. It says the measure of angle RST, so that is RST, tracing it with your finger. That's the big angle, okay? And notice we're given that measure at the beginning of the problem is 15x minus 10. So in the next step they substitute that. But we want to know what smaller pieces make up the measure of angle RST. Well, that's where we go to the two smaller measures of the angle put together make the big angle. So that's the measure of, if we fill in our letters here, RSP, P, the top half of the top part of the angle, remember it's not necessarily bisected, but the top part of the angle, RSP, and then the bottom part of the angle is PST. And RSP's label is x plus 25. And PST's label is 5x plus 10. Adding our like terms there, we get 6x plus 35. And moving some things around, we would get 9x and equals 45. And then dividing both sides, of course, we get x equals 5. So a little further down the page here, I want you guys to do this your turn, number 8. Make sure your two angles LMN and NMP have a diagram that is going to form a linear pair. So look back at the top of page 48 if you're not sure what that linear pair diagram should look like. And again, make sure that you know when two angles are sharing a side that the two letters that they have in common, M and N, okay, notice the vertex of each one is M, so be aware of that in your diagram, and it looks like M and N are the shared letters. That should be the shared ray. So make sure that you label algebraically so that the measure of one angle is twice the other, okay, and then see if you can find the measure of the angle that they're looking for, all right? See what you can do with that, your turn. Okay, I'm on page 50 here with Explain 3, where it's talking about using some more geometry with lines and planes and talking about postulates that kind of are always true when those things are interacting. Points, lines, and planes, as you know, are the building blocks of geometry, so it's important to know how they behave when they kind of get together in the same diagram, okay? Most of these I think are pretty self-explanatory, so I'm just going to have you read through them. Some of them are a little difficult to visualize, so tomorrow in class we're going to kind of do some exploring of this with some physical pieces of paper and string and things like that, so you can really kind of cement this idea in your head, okay? But just kind of read through these two pages, 50 and 51 here, and then I want you to do 50, 51, these two pages, make sure you read through them. And then I would like you to do, you elaborate number 12, okay, as another kind of your turn question. So we will check in on 3, 4, 5, 6, 8, and 12 from this lesson 1-4 tomorrow when I see you. Have a good one.